Hi YouTubers, we're here live on Twitch and we're going to do another senior maths challenge. This is the maths challenge from November 2014, so this is many years old now, and I think you can no longer find this on the internet. I've had to buy the past papers. The UK Senior Maths Challenge, if you've not seen one before, is for A-level students in the UK. It is aimed at 16 to 18-year-olds, and you don't need any maths beyond GCSE, but it's difficult, so you need to think of it. There's no techniques you need beyond that, but obviously these questions are very difficult. The way it's going to work is we're going to do 25 multiple choice questions. So we start with 25 marks, and if we pass on every question, we will finish with the score of 25. But for every question we get wrong, we're going to lose a mark, and for every question we're going to get right, we're going to gain 4 marks. So we can pass and get nothing, we can gain 4 marks, or we can lose a mark if we're wrong. So we're going to try not to be wrong. I've got the answers on my computer, but I haven't looked at the questions beyond copying and pasting them for this. The way it's going to work is that we're going to work out the answer and then see if it's there. That's usually the way to go with multiple choice questions. Unless it directly refers to the answers in the question, you generally want to go down that route. So we're just going to jump in and we're going to have a go at question number 1. What is 98 times 102? So this isn't too difficult. What we can do is, this is effectively the difference of two squares. That is going to be 100 take 2 multiplied by 100 plus 2. That's effectively that there. And then this is going to be a difference of two squares. That's going to be the same as 100 squared take 2 squared. 100 squared is 10,000, take 2 squared is 4, so I think it's going to be C. But you could just sit there and multiply that out, I believe. In fact, looking at the answers, you can just estimate that it's got to be C. I don't think it can be any other option there. We've not done that wrong, have we? 100 times 100 is 10,000, so it's going to be 4 less than 10,000, yeah. Okay. Question number 2. The diagram shows 6 regions. Each region is to be painted a single colour, so that no two regions sharing an edge have the same colour. What is the smallest combination of colours? So we're just going to, my guess is it's going to be 2 or 3. If you have this one as red, you can't have any of the 4 that surround it red, but you can have that one red. And similarly, I think if you have this one as blue, you have to colour it something. The only other one you can colour blue is that one, and then the last 2 sections can be the third colour. So I think it's going to be 3. There is a theorem called the 4-colour theorem, which means you can actually do any diagram in 4 colours or fewer. It took a long time to prove that, but I know it's not going to be 5. It can't be 5 or 6 based on the 4-colour theorem. Okay, so December 31st in 1997 was a Wednesday. How many Wednesdays were there in 1997? 1997 is not a leap year, so there are going to be 365 days in 1997. So it's going to be C or D because there's 52 weeks in a year, but it's 52 and a bit. So my guess is it's going to be D, but let's see if we can prove that. If we do 365 divided by 7, we get nothing, 5, 2, remainder 1. So there's 52 weeks and 1 extra day. So the 1 extra day is going to be this Wednesday here, and then there's going to be 52 other weeks which all have a Wednesday. So I think there's going to be 53 Wednesdays. After I'd spent 1/5 of my money and then spent 1/4 of what was left, I had £15 remaining. How much did I start with? So we have £15. That's going to be 3/4. So what we're just going to do is work backwards. We're going to do this calculation but reverse, and then we're going to do this calculation but reverse. So that's going to be 3/4. If we add back on that quarter, that's going to be 20. Because a quarter of 20 is 5, take off 15. And then what we're going to do, 1/5 of the money. So you've spent 1/5 to get to 20, so you must have started with 25. How much more? I could have just looked at the options there because it can't be any of the other ones. I should double check this. After I've spent 1/5 of my money, it gets me to 20, and then a quarter of 20 is 5, 15. Yeah, that works. How many integers between 1 and 2014 are multiples of both 20 and 14? So, to be a multiple of both 20 and 14, you have to have the same factors. Now, they've both got a factor of 2, so the common multiples between 20 and 14 are going to be the same as the common multiples between either 20 and 7 or 10 and 14, because that 2 is not going to matter. So what we're looking for is the first common multiple of 10 and 14 is going to be 140. If you do your 14 times table, the first time you get a multiple of 20 is 140. So it's just going to be those two times together is 140, and then 280 and so on. So we're looking for how many 140s go into 2014. So we're going to go 140 into 2014 and just divide that. So we'll just do how many 14s and then reverse it. So how many 14s? You get 1 carry 6, you get 4 carry 5, you get 3 and a bit. That's going to be, instead 14s into that is 143, so 140 into that is going to be 14.3. So you're going to get 14 full multiples and a bit. You're not going to get that 15th multiple. Again, looking at the options, they haven't even given you the option of 15, so you can't get that wrong. You can't round up. Sorry, someone's just messaged me. Let's have a look. Yeah, that's just people. I'm a popular person, you see. In this edition, in the addition sum shown, each of the letters T, H, I, and S represent non-zero digits. What is the value of T plus H plus I plus S? So here's the division sum here. So S has got two possibilities. S could be 2 and 2 is 4, or 7 and 7 gets you 4, and I think it has to be 7. If, just hypothetically, if S was 2, there's no value that I can be to get you a 1 there, so S cannot be 2. So 7 and 7 gets us 4 carry 1. And we've got I and I. So I could be 0 to get the 1, but I can't be 0 because then H would also have to be 0, and yeah, my guess is that they can't be different. So it could be 2002, sorry, 2007, but I don't think so. My guess is it's going to be 5 and 5, which gets us 1 with the carry. Then that would be 9, plus the 1 you carried gets you to 10, and then another carried 1, that would have to be 1 to get you 2. So 1957 are 4 distinct digits. My guess is it's going to be 1957. In theory, you could have 2007 plus 7. That works as well, doesn't it? 2014. So in theory, they don't say they're different. It says each of the letters T, H, I, and S represents a non-zero digit. Why does it have to be different? My guess is it is, and so because these are different, I'm going to go with that as my answer. We do know S has to be 7, but the other 3 are up in the air depending on whether you can have repeats or not. But that gets us 22 if we add them together, and that's an option, so I'm going to go with that. My second option would be D. Being absolutely stupid, it says non-zero digit, so you cannot have that as an option. Absolutely stupid. I was just trying to look to see if you can have repeats. I ignored the non-zero part, so that's fine. According to recent research, global sea levels could rise 36.8 centimetres by the year 2100. Now, this was done in 2014, so you're looking for 86 years. Roughly how many millimetres is that per year? So we're going to do 368 millimetres divided by how many years there are, and there are 86. And it says roughly, so we can estimate this. It says roughly, so we're just going to estimate this. So if you call that you could do that's 360 divided by 90, which is going to be 4. So it's going to be roughly 4. It's actually going to be a bit more than 4. Because we've rounded the numerator down and the denominator up, so we've actually made our answer smaller. So it's going to be 4 and a bit, we think, but 4 is our answer. The diagram shows 4 sets of parallel lines containing 2, 3, 4 and 5 lines respectively. How many points of intersections are there? Well, you're going to have the 2 line, they're going to kind of cross, so the 2 is going to cross with the 3, 4 and 5. The 3 is going to cross with the 4 and 5. The 4 is going to cross with the 5, and the 5 isn't going to cross with anything. So the 2 is going to cross with the 3 6 times. That's that bit there. And I'm just going to do the intersections, and there are going to be 1, 2, 3, 4, 5 intersections. So I think we've got something that looks like this. The 2 is going to cross with the 4 8 times, the 2 is going to cross with the 5 10 times, the 3 is going to cross with the 4 12 times, the 3 is going to cross with the 5 15 times, and the 4 is going to cross with the 5 20 times. And these crossings here would just be repeats of the ones down below, so we can't have those. There are 6 different ways to cross, sorry, 1, 2, 3, 4, 5, 6. Yeah. And so we've got our 6 different crossings. How many ways are there for 4 lines to cross? It's going to be 1 times 2 times 3, isn't it? Yes, so 6. So we're going to just add these together. So we've got 20, 40, 50, 65, 71, which is an option we've got. Thankfully, they haven't made the options close together again, so even if we were slightly off, we would know it. Which of the following is divisible by 9? 10 to the power 2014 plus a digit. So there is a trick for divisibility by 9, and is the digit sum is also a multiple of 9. So for example, 27 is in the 9 times table because you can just do a quick check that 2 adds 7 is 9, and that will work for any number in the 9 times table. If you had 99, you would do 9 and 9 is 18, gets us 18, and 1 add 8 gets you 9. So the digit sum of anything in the 9 times table adds up to 9. A digit sum is just the digits added together. So your 10 to the power 2014 is going to be something like that, with 2013 zeros and a digit at the end. And to get this digit sum to add up to 9, you'd need the last digit to be an 8, because 8 add 1 gets you 9. It's going to be D. A rectangle has an area of 120 centimeters squared and a perimeter of 46. Which of the following is the length of each of the diagonals? Okay, so we want x plus y twice to be 46. So we want 2x plus 2y to be 46. We're just going to solve this with an equation, I think. And then separately, we want x times y to be 120. So, 120. So we can say our second equation is y is going to be 120 over x. So our first equation is now going to become 2x plus 240 over x is 46. We've stepped up a notch here. We're going to get quadratic here. We're going to get 2x squared plus 240, take 46x is 0. My guess is it factorises because it's an uncalculator. We'll take a factor of 2 out first, so we've got x squared, take 23x plus 120, and that is 15/8, isn't it? So 15/8 gets us 120, but it also adds up to 23, so you're going to get x take 15, x take 8. So x is so y will be the other one because of this fact here. We know x times y is 120, so if x is 15, y will be 8, vice versa. But according to our diagram, x is going to be 8. So our diagram, x is 8, y is 15, and you're going to get pi Pythagoras triangle here, and then if you've got 15 and 8, it is 17 as one of the Pythagorean triples. Incidentally, there is a set of triples. There are two sets of triples, and they both stem from the same original triple, so nothing to do with the question here. It's just the reason I knew 17 quickly is because I know some triples. And then you've got the triple of 3, 4, 5, and any multiple of that gets you another one. So that produces 3 sets of triples. So you could have 6, 8, 10, and so on. And any multiple of that will get you a triple. Another set of triples is you've got 5, 12, and 13, and that will get you 10, 24, 26. And again, they're all Pythagorean triples, as in work whole number answers to Pythagoras. And then the third one is if we just take this one and switch it slightly, we can have 4, 3, 5. What you do is you can double that one, and you then get 15, 17, and then you can do it again, 12, and gets you 35 and 37, and 16 would get you, I should be able to, so 4, 16, 36, squared, 64, so 63 and 65. And the way it works is that basically these numbers are either side of 4, these numbers are either side of 4 times 2 squared, so 16, these numbers are either side of 4 times 3 squared, which is 36, these are either numbers 4 times 4 squared, 64. And I think there's a more elegant way of doing that, but they're also from the same set of Pythagorean triples, so I'm just using that triple there, which I knew was a triple. But you could do it, you could do 15 squared plus 8 squared, gets you 279, I think. Just a bit of a detour, apologies for that. A Mersenne prime, and I've read about these before, is a prime of the form 2p take 1 where p is also prime. One of the following is not a Mersenne prime. Which one is it? P is also prime, so p is prime in all of those. So we're just going to work it out, I think. So 2 squared is 4, take 1 is 3, that works. 2 cubed take 1 is 7, that works. 2 to the power of 5 take 1 is 31, that works. 2 to the power of 7 is 128, 127. Is that right? 2, 4, 8, 16, 32, 64, 128, okay. Doesn't go in 17, doesn't go 13, doesn't go 11. It's less than 17 squared, so I think that's prime as well. So let's just double check this. 2 to the 11 would be 256, 512, 1024, 20, 23. And is that divisible by something? So we could just spend some time working out. I think it's going to be this last one, but is that prime? Probably not. Does it go into 7? 2, 6, 8, 6. Yeah, it divides by 7, so you're going to get that will be 7 times 269, I think, which is not prime, so that's our answer. I might be wrong with my multiplication there, but I'm close. 727 is 140. I might be wrong with my... No, it's not 6, is it? It's going to be 8, 289, there we go. Right. Karen has 3 times the number of cherries that Lionel has, and twice the number of cherries that Michael has. Just going to read that again. I'm a bit ill, so let me off. Twice the number of cherries Michael. Okay. Michael has 7 more cherries than Lionel. How many more cherries do Karen, Lionel, and Michael have? How many cherries do they have altogether? So Karen has 3 times the number of cherries that Lionel has. So let's say Lionel has Yeah, Lionel has X, Karen has 3X. And twice the number of cherries that Michael has. So Michael has 3/2X. Michael has 7 more cherries than Lionel, so half X equals 7. The difference between Lionel's and Michael's cherries is 7. So X equals 14. So we're going to get 14, 42, 21. And then add these together. It's going to be 56, 76, 77 cherries, which is an option. Right. We're getting towards the end of the easy ones. I say easy, often the first 15 are the ones you should be aiming for, and after that it's just a bit of a potluck, I think. Each of the 5 nets is made from 6 squares. Both sides of each square have the same colour. Net P is formed to form a cube. How many of the nets Q, R and S can be folded to produce a cube that looks the same as that produced by P? So we're going to get a cube here, and those 3 sides there are going to connect. So we're going to get a cube where you can see 3 adjacent faces that are shaded, and then at the back unshaded. Okay? So visualizing this one will not touch that one, but they have to all meet at one corner, so they're all going to meet at one corner. So this one is not one. That one is not one, because they won't all meet at a corner. Again, that one won't touch that one. This one that one won't touch that one. They won't meet at a corner, will they? You're going to get these 4 down the middle are going to go wrapped around the cube, and then the 2 I've circled will be on opposite faces, so you're not going to get this. And then the last one, I think it's the same. That one's not going to touch that one, so I think it's going to be 0. How many can be folded? There's only one way, well, there's 2 ways to fold them. That's why they've said that both sides of the square are the same colour. You could fold them outwards or inwards. So you can make the folds one way or the other way, but it shouldn't matter in terms of shading. So I think it's going to be 0. Yeah. Right, back to some algebra. Given that 3x plus x over x take 3y is -1, what is the value of that? So, the reciprocal of this is also going to be -1. It's going to be 1 over -1. The reciprocal of this is x take 3y over 3x plus y, and that's going to be the same as the reciprocal of -1, which is -1 over 1. Sorry, 1 over -1, which is also -1. And oh, hang on, might be a bit easier. We can just say that 3x plus y equals this times -1, so it's going to be 3y plus, so take x. They're going to be the same. So you're going to get 4x equals 2y, or 2x equals y, and then we're just going to work out what that would be. So that's going to be, so the first one's going to be 5x over negative 5x is negative 1. So x is 1. So x equals 1. And therefore y equals 2. So then we're going to go back to this one, we're just going to substitute 1 and 2 in, and we're going to get 1 plus 6 over 3 minus 2. 7. Oh, I like that. I like that, that was nice. Yeah, I did not think it would be 7 there. The figure shows that the figure shown alongside is made from 7 small squares. Some of those squares are to be shaded, so that at least 2 squares are shaded. Right? And 2 squares meeting on an edge or at a corner and not both shaded. How many ways are to do? At least 2 squares are shaded. 2 squares meeting along an edge or at a corner and not both shaded. So this one can't be shaded. That one can't be done. So I think we're just going to do some things. So if this one is shaded first, you've got you can't do that one or that one. So you can have this one and that one is 1. You have this one and that one is 2. Or you could just have that one is 3. So I think if this was going first, there were 3 possible combinations. Oh no, there's not. There's more than that. That's just, well, I don't know how to write this down in a sensible way. Alright, so let's just, I'm going to number them, and this is bad. Let's just number them. 1, I'm not going to number this one because we can't shade that one. So I've got 1, 2, 3, 4, 5, 6. So we have to do at least 2. So we could have 1 and 3, 1 and 4, 1 and 5, 1 and 6. But you could also have 1, 3 and 5, or 1, 3 and 6. Yeah? If you have 1 and 4, you can't do another one. If you have 1 and 3, you could also have 1 and 5 and 6. So if we shade in 1 first, that's 7 options, 6 options. The other possibility is we shade in 2 first, and that eliminates 1, 3 and 4, but you can have 2 and 6 or 2 and 5, and you could also have 3 and 6 or 3 and 5. Gets us 10. I don't think it's possible we can get 4 more out of that, because we have to shade 2. You can't shade 2 and do any more than 1. You can't shade, so the only way you can get 3 is to do 1 first. You've got to get 1, 3 and 5 or 6. So we've done 1, 2 and 3. You can't do 4 without shading in one you've already done. Yeah, it's going to be 10, I think. Now we're on the hard one, so we're on question 16 now. Right, okay, so finish the coffee. The diagram shows a rectangle measuring 6 by 12 and a circle. 2 short sides of the rectangle are tangents to the circle. The circle and the rectangle have the same centre. So we'll do it in blue. So they have the same centre. The region that lies inside both the rectangle and circle is shaded. What is its area? The diagram shows a rectangle measuring 6 by 12 and a circle. So we know that, my guess is we're going to have to join those up. And we know that the diameter of the circle is the same as the length of the rectangle. So we know that this is going to be 6. And this is going to be 6. And in fact, you can, so there we go. If we split it up into those 4 shapes, what we can do is work them out separately, because we're going to have a fraction of a circle and What fraction is it? We know the height is 6, so we know, there we go, so that's 6, that's an equilateral triangle, so we know that this angle's 60, that angle's 120, and we can just use a sixth of a circle twice, and then the half AB sine C twice, so we're going to use two things, so we're going to work out this shape here, which is going to be, there's going to be two of them, so we're going to have two of them, and it's going to be a sixth of the circle. The area of the circle is pi, is the area we're after. What's its area? Pi times 6 squared. It's going to be 6 times 6 squared is 6 pi, 12 pi for both of the x's. And then we're going to separately have, call it y. So y is going to be half, and again there's two of these, half times a times b times sine 120. Sine 120 is root 3 over 2, so we're going to get 36 times root 3 over 2, or 18 root 3. So we're going to get, it's this first one here, isn't it? 12 pi plus 18 root 3. Yeah, okay. The fact that when you do this and you get one of these answers that isn't, unless you've made the obvious error they think you're going to make, you're not going to get that answer by accident. So if you get an answer that's in this option of 5 awful answers, then you pretty much know you've got it right. So if you're really stuck on this question, if this is a question that's flooring you, what you can do is look at the answers, and not to see which one you think it is, but to give you a clue. So one clue is they've all got pi's in it, so at some point you're going to work out areas of some part of a circle. And the other clue is they've all got a root 3 in it, and you've got to think, how can I get a root 3 from my initial diagram? And one of the only ways to get root 3s is to do trig, because sine, cos or tan of certain values will get you a root 3. An oil tanker is 100 kilometres due north of a cruise liner. The tanker sails southeast at a speed of 20 kilometres per hour, and the liner sails northwest at a speed of 10 kilometres per hour. What is the shortest distance between the two boats during the subsequent motion? Okay. So if you have an oil tanker is due north of a cruise liner, the oil tanker is going that way and the cruise liner is going that way. Oh, hang on. No, the oil tanker is going southeast. Oh. So right, and then the distance initially is 100 kilometres. The bit when there'll be a point where the perpendicular distance between their two paths, so it'll be probably something like that, and think perpendicular, that will be the shortest distance, I think. And because OT is travelling twice as fast, my guess is it's going to be this thing, it's going to cut this line in thirds. So let's give that a go as a guess. I think this is going to be 100 isn't going to do it. So I'm going to say that's 200 over 3 and that's 100 over 3. So that's 2/3 of 100 and 100 1/3 of 100. And then we know that angle there is 45 degrees because the angle from southeast to south is 45. And we know, oh hang on, we know that that's going to be 2, that's going to be x. Oh, so they're similar triangles. I think they're similar triangles, so we don't need to know what x is, we just need to find out one of these distances and then we can double it. So how do we find out that distance? Because that's also going to be 45 degrees there, isn't it? Oh, and that's 90, and that's 45. They're just right angle triangles, aren't they? So that's 45 as well. So we can use just trig, and we're going to find out, we're not going to find out x, we're going to find out this value here. So we'll call that question mark. So I'm just going to highlight that triangle, and we've got a triangle which is that's going to be 100 over 3. They're going to both be 45. And we're working out this height here, which is actually going to be the same as the base because it's of triangles. And we're just going to use cos or sine. Doesn't really matter, does it? So we can say that opposite over. So we can say sine 45 equals question mark over 100 over 3. So we can say sine 45 is root 2 over 2 equals, I'm going to call it question mark x, equals 3x over 100. So it's going to be 50 root 2 equals 3x. There we go. So x is going to be 50 root 2 over 3, but the length of this line is 3x. So it's going to be that one there. Yeah, the line we were looking for is going to be, this is going to be the same as that 2x up there. So they're going to be the same. Yeah, alright, I like it. Beatrix decorates the face of a cube whose edges have length 2. For each face, she either leaves it blank or draws a single straight line on it. Every line drawn joins the midpoint of 2 edges, either opposite or adjacent as shown. What is the length of the longest unbroken line that Beatrix can draw on the cube? Alright, so you've got, this is going to be difficult to visualise, so you've got your cube, and Beatrix is going to be drawing lines on it, and the lines are either going to go from the midpoint to the opposite midpoint, or from the midpoint diagonally. Now the longest unbroken line she can draw, yeah, single straight line, so you've got to have a line in every face. So if you did that line, hey Caleb, and that line, you then couldn't go down the next face because then you'd cut off this face here, or this face nearest to us. So we can't have a third straight line. I wonder if, my guess is that we can have 3 straight lines and 3 non-straight lines. So if we did, could we get 4 straight lines? That would be the good one. So what if we did that, then that. Now we can't connect these two up, but we can go across the bottom there, up and you'd have to go to this side here and then across that side there. So, oh dear, can't undo. So the black is our line, the black is our, trying to visualize this, I think we can get 4 straight lines. So the black is our line, and then the green is going to be our cube. So the dashed lines here are the cube we don't see. Now I hope you can see this for us. We're going to start here, we're going to go up. You can't quite see where my mouse is. You're going to go up, you're going to go across, you're going to go down. So we've done the 3 faces we can see. We're then going to cross the bottom. And then from here, we've just got the back 2 faces to do, but we have to go diagonally to the midpoint of this side, and then we can do a straight line there. So we've got a straight line on the front 2 faces, but not the top, and then the bottom 2 faces, but not the back. So I think we've got 4 straight lines. So we've got 4 2s is 8, and then we've got, this is going to be a root 2 because it's going to be a 1 by 1 root 2 length. It's going to be 2 lots of root 2. It's going to be 2 root 2. It's going to be 8 plus 2 root 2. The diagram shows a quadrant of radius 2. Quadrant of radius 2 and 2 touching semicircles. The larger semicircle has a radius 1. What is the radius of the smaller semicircle? So the whole length is 2. The radius of this one is 1. So that means maybe we'll need that line there as 1. And what we're looking to get is that line there. Is that a straight line? Is that definitely a straight line? It looks like it would be. Yeah, because I think it has to be. Let's see if we can formulate a reason why. I think that because 2 circles touching would effectively squash a tangent together, and a tangent meets a radius at 90 degrees. If that's 90 degrees, that's 90 degrees as well. So I think that's a straight line. So I think we've got some knowledge there. We know that's 1. We don't know any angles yet. We know this. So, hum. Any ideas, anyone, if anyone's watching? Might have to come back to this one. Yeah, or an angle. I think an angle might help us as well, because if we had this angle, for example, you could work out this angle, and then you can maybe use some trig, because if you're looking at the answers, you've got 2 lots of root 3 in there, so there might be a trig value coming in, maybe. You could. I don't know if we can use the fact that they're both in a quarter of a circle. Yeah, I'm going to pass this unless anyone's. The tangent to the midpoint of the larger circle. Yeah, I think we're missing something. We can do it because they're not impossible questions. I just think we're missing a geometrical fact somehow. I'm going to come back to that. The diagram shows 6 squares with sides of length 2 placed edge to edge, or as a radius of the smallest circle containing all 6 squares. So the widest point is here to here. Or here to here. So I think if the midpoint at the centre of the circle was that, if that's your centre, that point is far away, which is the same length as that point, the same length as that point. And I think if you had a circle, every other point on that shape, if the circle would hit those 3, this is an awful circle, apologies for that. Every other place on that shape is smaller, and you've got basically a circle with 3 of those points on the edge. You can't really make any smaller. So I think it's just going to be that length there. So this is squares of length 2. So this is going to be, we're looking for a Pythagoras for that distance there inside 2 squares, which is going to be 2, 2, and 2. So it's going to be 4 squared plus 2 squared square rooted, which is going to be 4 squared plus 2 squared square rooted. It's going to be root 20 or 2 root 5, which is option A. Yeah, I think that's right. I don't see us getting any smaller. That's larger, that's larger, that's larger, and that's larger. Yeah, there's no way. We've got one that works, and of the 5 answers, it's the smallest answer, so I don't think we can get any smaller. It's not a good proof, but it's a proof that says I don't need to keep checking, I can do a better version because I've got the smallest answer on the list. Alright, we're now on to the 5 difficult ones at the end. These are potentially very tough. And we've got another geometrical one. I'm usually good at them, but we got stuck on 19. If anyone wants to draw a 2-dimensional shape whose perimeter passes through all of the points P, Q, R, and S on the grid shown, which of the following can she draw? A circle, an equilateral triangle, and a square. So a square's easy. You can just do 6 by 6 by 6 by 6. So a square, we can definitely do. Alright, so we can do a square. Let's have a look at the other 2. An equilateral triangle. And that is a different gradient to that. But could you extend that and then, even if it was slanted, you think you could probably do that if there's a better way of proving that. Well, let's see what the options are. What are the options? Oh, the options are either 2, 3, or none. Well, we can definitely do 1. So we can either do, yeah, we can definitely do 1. So can we do a circle? So for a circle to go through them all, you basically, if you have 2 points, so let's say P and S and the circle goes through both P and S, then the centre of the circle has to be on the perpendicular bisector of P and S. It has to be somewhere on there. You can do a very similar thing with R and S, or Q and S, but Q and R, for any centre to go through Q and R, it would need to be on that line, and I don't think you can have a centre on both of those lines. If you have one here, a circle will go through Q and R. If you have one on here, a circle will go through Q and S, but I don't think it's possible to get one that goes through all. Yeah, so I don't think a circle's possible. Equilateral triangle does have equal angles and equal sides. Give me a sec, let's see if I can visualize the triangle. I don't think a circle's possible. Let's just see. So basically, if you've got any 3 points, I believe you can do a circle through them always, but it's the 4th point that's going to let us down. So how could we do an equilateral triangle? Okay, so how about this? We've got an equilateral triangle that goes through those two, and that's our base. I think there's an angle there at 60 degrees at some point further up that way, at 60 degrees, R goes there. And then what you can do to make it at S, once you've got 60 degrees, there will be a line that cuts through S. I think at some point you just effectively extend that out equilaterally. If that's not a mathematical expression, but you extend it out, equilateral triangle, going through those 2 degrees until it hits through S. Has to be. I don't think I like that, but we can definitely do a square, and I think we cannot do a circle. So I think there's a way to do an equilateral triangle. Is there a different edge we could use? She wants to draw 2 dimensional shapes as perimeter passes through. Yeah, but you're saying that because the grid isn't extending forever. I think the assumption is it is. So I think you can definitely do that. I think you cannot do that. And I have a feeling that we can do an equilateral triangle. What about an equilateral triangle that goes that way? It goes like that. And again, once you know that's 60 degrees, you can you'll eventually keep extending that base back and back and back until you go through point S. I think you can do it. I think you can do that. So I think it is, what's our answer going to be? Only 2 and 3. I think that's our option. I hate that. I do not like that. Yeah, I think the key is that the base can't go through P and S. It has to either go through P and S have to be on opposite edges, but they can't. The base of the equilateral triangle can't go through P and S because Q and R won't line up. So I think something like this would work as a rough estimate. Don't like it. Right, a bag. Oh, I like probability. I think if it's probability, a bag contains blue and yellow marbles, N blue and N yellow. A marble is selected at random from the bag. Its colour is noted, and it's returned to the bag with K marbles of the same colour. A second marble is now selected at random from the bag. What is the probability that the second marble is blue? Hang on a minute. So we're picking one out. We don't know what colour it is, and whatever colour it is, we're putting it back in along with more of that colour. So what's the probability the second marble is blue? Well, it depends what the first one is, doesn't it? If the first one is yellow, I think it's this. because there are m blue out of m blue, n yellow, and k yellow. But if the first one is blue, it's that one. Which means it can't be either of them, because it's dependent on what we pull out first. So my guess is it's the last one, because the first two don't have k in it, unless k cancels out. Alright, let's think about it. So let's assume that it's blue given first is blue. You think k cancels out? Then it's probably going to be A then, if k cancels out. It's going to be A or E, I think. So the probability it's blue given the first is blue is the probability it's blue given the first is blue is the probability of it being blue times the probability the first is blue. So it's going to be the probability of it being blue given the first is blue is going to be that one, m plus n plus k, times m over m plus n. And then the probability of it being blue given not blue is going to be this one, C, as in there were no extra blue ones in, because the first one we picked was yellow. And then if we add these two together, that will be the probability that it is blue. Yeah, they're the four options. Blue given first is blue, blue given it's not blue, yellow given first is blue, yellow given, yeah, okay. So these, so we're going to add two of the four options together, and then this will simplify into, if we multiply that, we're going to get, well, the denominator is going to be the same. So we're going to get m plus n plus k times m plus n over m squared plus km, and then I'm going to add this one, so we're going to get mn over m plus n plus k, and oh, this is going to cancel out, yes, so there's going to be no k, so adding them two together, I'm running out of space here, so it's effectively the probability it's blue is those two added together. So this plus this and the denominator is the same, you're going to get, and I'm going to factorise it now, you're going to get m plus k plus n over m plus n plus k m plus n. I've just added the numerators together and factorised for a k with an m, so you can actually divide those. Equals m over m plus n, which is a. Ooh, I like that, that's nice. That it is not conditional to how many extra you add in, it's just going to be the probability you pick a blue the second time is the same as the probability you pick a blue the first time. That's nice, isn't it? Which of the following have no real solutions? Two to the x is less than 2x is less than 2 to the x is less than x squared. X squared is less than, oh god. Right, so, oh dear, what do I do here? Do I just ignore one of them? So what I could do is ignore the one that's hardest to graph and just graph these. Because that's just two different conditions. It's either going to be x squared is less than 2x or x squared is more than 2x. And if we had a graph, y equals 2x looks like that. Y equals x squared looks like that. And that point there is where they're equal, so that's when x is 2. So 0. So 2 to the x is always larger than or equal to x squared. It isn't, because when x is negative, it's lower. So in a second, so we've got the graph y equals x squared and y equals 2x. Yeah, and then we've got a third graph that I'm going to do in a different pen. We've got y equals 2 to the x. So y equals 2 to the x looks like it hits at 1, and then it goes really big. So when x is 2, 2 to the x is 4. So it's actually going to go through the same point here. It's going to go through this point, and we need to decide. The few options. It can either go, I think it goes under line 2 equals x. I think it goes like that. It definitely overtakes line 2 equals x later. Can we prove that? When x is 1, when x is 1, they're the same, aren't they? So I think this point is when x is 1. So yeah, I think it goes like that, and I think it has to, oh hang on. It doesn't go under, it intersects with it, doesn't cross. I think so. I think when x is 1 and a bit, y equals 2x is bigger than y equals 2 to the x. Oh dear. Oh dear. And then we have to decide what's bigger when x gets really big, and I think it has to be 2 to the x. So I think I've drawn my graph wrong. We're going to redraw this. I'm going to focus on that area there, because I think there's going to be some of these graphs where there's no, yeah. So we're going to redraw this, and we are going to have black for axes. So we're going to make a much larger axes. We're going to get 3 different graphs. We will do y to the 2x as roughly accurate according to the grid points we've got here. That's y equals 2 to the x. In that second graph, when x is 1, 2, 1, 2, they're going to meet. That's going to be the meeting point, and that's going to be 1, 2, 3. So roughly like that. So we're going to get a second graph. Alright, thank you. I'll look at that in a sec once I've done these graphs. So we're going to get y equals x squared. Y equals x squared goes through 1 and 1. So it goes something like y equals x squared goes beep, 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 beep. And then at that point it will overtake. Okay? And then finally, that is y equals x squared. And finally, we're going to get y equals 2 to the x. So we know that's going to go down here. When x is 1, it's going to meet the straight line. It's going to meet the straight line again. So it definitely dips underneath the straight line, I think. It definitely dips underneath the straight line. And I think it doesn't dip underneath the quadratic, because it's going to get bigger quicker, and it will equal the quadratic at that point. So I think y equals 2x effectively is a tangent to the quadratic, but isn't strictly lower than it. That's why they're all not equal to. So let's get rid of that and try and work out areas of the graph where each of these things is true. Right, so, right, oh dear. So this area of the graph, the order is x squared is biggest, then 2x, then 2 to the x, and 2x. So that's this one. So that one is true for the bit where my red line is. And then we have some overtakage in this area here. We have a different order. We have the largest one being y equals 2x, then x squared, then 2, y equals 2 to the x, then x squared, then 2x. So that's that one there. And that order doesn't change until we get here. And that order is 2 to the x, then 2x, then x squared. So that's that one. That one works as well. And that doesn't change again until we get to this point here, where it goes 2x is the largest, then 2 to the x, then x squared, which is that one there. And that doesn't change again until this last one, but that last one is the same as the second one. That's going to be 2 to the x, then x squared, then 2 to x, which is that one again. So I think the answers are 3 and 5. I think that's our answer. Oh, that was nice. That was difficult, but that was nice. We've got 2 questions left, plus 1 we need to go back on doing. Yeah, well, we got an answer that was there. We got 2 that we got 2 that we couldn't make work, and that is a combination of 2 and an answer. So I think I'm happy with that. I know definitely some of these have to be true. The 6 has to be true because 2 to the x is by far the largest when x gets really large. So 6 has to be true, which already eliminates. Oh, it doesn't eliminate any of them, does it? Oh, okay, but you get the idea. Which of the following is smallest? So we can write this as 10 minus root 9 times 11 is 19. Hang on. We can write that like that. We can write that like 64 take. Yeah, I think this is going to work for all of them, isn't it? 64 is going to be root 63. 25 take 24. 4 rooted. 9 take 81 take root 80. Now root 49 take root 48. Which one of these is the smallest? If you take these away, you don't get root 1. Root 1 is not going to be the answer to these. But when you're taking these away, the difference between a very large square root and an almost as large square root is going to be smaller than 2 small square roots. And you can, don't know if we can prove that, but the square root of 2 take the square root of 1 is going to be 1.41 take 1, which is going to be 0.4. And 0.4 is a large value, but the square root of 100, one bit of that is going to be, root 99 is going to be almost 10. It's going to be 10 point. So I'm almost certain it's A. I think the difference between these two, well, it has to be A or C. It has to be A or C, because if you think about it, they're all in their unsimplified third form. They're all 1 away, and you're looking for, as square roots get larger, does the gap between them get smaller? It does. So I think it's just got to be A. I know it's A. I'm just trying to explain it poorly. Well, that was a lot easier than that one, and that one. Yeah, so Ignatius, someone in chat has said it very well. The amount of increments you need to go in square roots gets larger and larger the bigger the root gets. So to get from root 4 to root 1, that's 3 steps, and that's 2 and 1, so 3 steps to get between two whole numbers. But when you've got root 81 and root 100, that's 19 steps to get from 9 to 10. So the number of steps it takes you to get from one to the other, given they're both one apart, is 19 steps in terms of square root steps versus 3. So it gets larger, so i.e. the gaps must get smaller as we go up. That's a nice way of saying it. Figure 1 shows a tile in the form of a trapezium where alpha is 83 1/3, so that's the angle there. Several copies of the tile are placed together to form a symmetrical pattern, part of which is shown in figure 2. It's like a zigzag pattern. The outer border to the complete pattern is a regular star polygon. Figure 3 shows an example of a star polygon, so it goes all the way around. How many tiles are there in the complete pattern? Well, that has to be 180 minus alpha, or 96 2/3. I'll say, I'm just going to say beta is 96 2/3. Don't know if we're going to need it. That's beta. So if we have So we've got, I should zoom in a bit, we've got that, we've got, I'm just going to write that, we've got one like that attached to one like that, attached to one like that, and the twist comes from here. They twist a bit, so we need to find how much twist that is. And again, you've got one up there. So how much twist is that? Well, this length's 2, so that's 1 and that's 1. We know that that is alpha plus beta. And that's straight, so I've drawn it badly, that's straight down there. And that's beta, so that's a bit more, there we go, there's the twist, you see. So basically, the angle it's deviating from north there is going to be the same as the angle it's twisting around there, which is going to be 6 2/3 of a degree, I think. So that twist there is going to be the same. That twist there, I think, is going to be the same as the twisting around here, I think. And if 6 2/3 goes into 360, we should get an answer. So 6 2/3 is the same as 20/3. If we do 360 divided by how many twists it's going to make, we get, that's the same as 3 times 360 over 20 is going to be 18 times 3 is 54. Now I think I've gone wrong here, because I thought that would get me, that's 2 tiles to get a twist. Oh. Because it takes 2 tiles before you twist, and then 2 tiles before the next twist. So I thought it would be 108. What have I done wrong? What have I done wrong? I think it should be 108. 2 tiles gets you a twist of 6, 2, 3, 2/3. 6 and 2/3 goes in 54 times, so it should be 108. Well, I'm probably going to guess 54, but I don't think it is. Have I got the twist wrong? 83 1/3 is 96 2/3. They add up to 180. Oh, unless it's... Yeah, because I think basically you're going to get a zig and a zig and a zig, and you're looking for, between zigs, how much does it change? And between zigs, there's 2 tiles. I think it's... Oh, I don't know. I'm clearly wrong because there's no number near 108. That's what I want to guess, 108. Which is going to be twice 54. I don't know. Anyone got any ideas? Two to get a twist, 2 to get a twist, 2 to get a twist. I'm going to guess 54 unless someone can tell me otherwise, because I've got an answer that's there. And 6 and 2/3 goes in nice. Is it not at 6 and 2/3? Maybe it's like... No, because if I make the angle smaller, I'm going to need even more tiles. Oh, hang on. Do you think it's 6 and 2/3 twice? That you're doing 6 and 2/3 here somehow, and then 6 and 2/3 and 6... I'm going to guess 54. Don't know. But I've got a number that's on the answer, so I'm going to go for it. And we missed one out. Let's go back to it. So this is the one we couldn't do. The diagram shows a quadrant and radius 2 and 2 touching semicircles. The larger semicircle has radius 1. What is the radius of the smaller semicircle? In theory, I've got an hour and a half to do this. I've got 13 minutes left according to my stream timer. So... You have a thought, okay? I'll take thoughts. I'm missing a fact here. That's it. You're saying the top circle consumes some area from the top area of the quadrant. And we know that's 1 as well. And that's 1 there. It does constrain the circle, yeah. This is as big as you can fit it in, basically. It's the biggest circle you can fit in this gap. I mean, I don't know. It can't be that, because pi would be to do with areas, really. We're not dealing in radians, so you're not going to get a pi. If you extend this line, do you get a similar triangle here and here? That's a right angle as well. Is that angle the same as that's the same as that one, isn't it? Oh, I'm just writing stuff on there. I think I might have to pass. There should be some. Yeah, I know. There's a fact I'm missing and I can't see it. I know. I'm gonna have to pass this one. I think it's a bit of a shame. You imagine it's B. I'm not gonna guess, but you're gonna guess B, are you? Alright, so we're going to go back to the start. I'm going to mark it. So if you've done this at home and you want to mark it. Oh wait, well if you can get an answer before I get to it, I will take it off you, but at this moment in time, I need to... Right, I'm going to start marking it. I'm going to mark the first 12, and if you've got an answer by the time I've done it, I will listen. Yeah, that is not right, I'm afraid. Right, so number 1 is C, have some marks. Number 2 is B. Number 3 is D. You no longer have a guess, that's fine. Number 4 is A. Number 5 is C. Number 6 is B. I haven't got the solutions, I've just got a list of answers. 7 is B. 8 is C. So this isn't great, I won't even be able to work out what to do. 9 is D. 10 is C. 11 is E. 12 is D. And then change my answers to the other list. 13 is E. Hang on. Oh, I'm being stupid. Absolutely stupid. Yeah, it is E. I basically says that they meet to the corner. They don't. Those two don't meet. And so in theory, it's all of them. By the same reason I said it was none of them, it's all of them, because I've got my diagram wrong. Oh, silly. Right, so that's one we got wrong. We got that wrong. 14 is E. 15 is C. Now on to the hard ones. 16 is A. Change the green pen. 17 is C. 18 is D. 19 is E. So we didn't get that. 19 was E. 20 was A. 21 is B. I found that difficult. 22 was A. That was nice. 23 was E. Not a fan of that one. 24 was A. That was actually quite easy. And 25 is B. So we got it right, but for some reason I think it should be 108, and it's not an option. So thankfully it wasn't an option. So it takes 2 to get a twist. Oh. Right, so I know why I thought it was 108. The twist isn't 6 through 2. You're going to have a twist. You're going to get the difference between B and A as your twist. So that twist is actually going to be 13. 13 and a third. The twist is going to be 13 and a third, i.e. the difference between A and B is your twist. And how many 13s and a third go to 360? That is 27, and that gets you the 54. Yeah, okay, that makes sense. So I assume that the twist was that, but you're twisting... Yeah, you're twisting a bit more than that each time. You're twisting the difference between them, because you twist by the excess of B there and the less the excess of A there. Alright, okay. So, get a score then before we finish. We will get a final score. We got some answers then. So we got 25 marks because we were brilliant at the start. We are going to lose 1 for getting 1 wrong. We answered 24. We got 1 wrong, so we get 23 lots of 4. Is going to be 18, 92. So in total, we're going to get 25 that we started with. We're going to lose 1 and get 92. So we're going to get 26, 118 out of 125, I think. I've done that wrong, maths wrong. Yeah, okay. So that's what we got. So there were 2 we just lost the 8 marks for, and 1 of them were left blank, so we lost 7 marks basically. Okay, so if you did better than that, please put in the chat. If you could solve the one I couldn't solve, because I haven't actually got the solutions this time, and I've just got a list of answers. So if you can solve the one I didn't solve, which is number 19, can you post that in the chat below? If you're watching this live, the one for this academic year will be out next weekend, probably, or whenever I've got time to do it. And if you're watching this on YouTube, same again, I can't do it until the week has passed because schools do it on different days. So it'll be out probably Wednesday, the week after. No worries. Thanks so much for watching, and I will see you soon. Bye.